All right, so this is our first Thevenin problem that we're going to look at today. This problem is asking us to find R Thevenin and V Thevenin. Okay. So they give us a very simple circuit to look at. We have our open terminals defined here. Sometimes they don't explicitly say that these are VOC, but just know that the open terminals over here are going to be VOC. Okay, so let's run through our steps. So step number one, do we see any dependent sources? And looking through here, I don't see any, so we're good. So now let's go and zero out our sources. So that means we'll take our batteries, turn them into wires, and our current sources, and turn them into clipped out wires. Just got to make sure it's still recording. Don't want to make that mistake again. Okay. All right, so let's go draw that circuit. So here, I only see one current source. So when I go and redraw my circuit, here, and bam, this is going to be R1, this is R2. Then we'll draw VOC, and then plus and minus. Okay. So this is our new circuit, and this is how we're going to find, this is what we're going to use to find R Thevenin. Okay. So if we're treating this like a battery, we're saying, okay, so some current's going to leave here and just head into this circuit. Okay. So looking at this, if we have a current leaving here, travel up through this way, go through this resistor, but then it'll hit this point right here. So it sees that it has two options. You can either go this way, where there's an open wire, or it can go this way, where there's a resistance. Now, typically, current wants to follow the path of least resistance, but current cannot travel over an open wire. It has nowhere to go. It can't make that jump right here. So this current will just go completely through this resistor. So it skips over this open terminal. So we can effectively just go ahead and ignore the open terminal part. So that does nothing for us for this circuit. Okay. And then if we're working this way to find our equivalent, we'll notice that these two are on the same wire. They're going to be in series. So I will write R series 1, and that'll be R1 plus R2. That will be 10 plus 40, which will give us 50. So 50 ohms. Then draw it real quick. So this will be R series 1, VOC, plus and minus. Okay, so now I only have this one resistor and this one source. So therefore, our R series 1 is equal to our R equivalent, which is equal to R Thevenin. So therefore, our R Thevenin is 50 ohms. All right. So that's part one. So we need part two now. So to conduct part two, what we're going to have to do is go back to the original circuit. So we'll jump back to this original circuit, where this is 5 amps. Still have our R1. This is R2. Now this is plus, minus, and that's VOC. So this is our original circuit. So let's think about how we can find VOC, because we say VOC is equal to V Thevenin. So if VOC is V Thevenin, we know that branches in parallel have the same voltage. So the voltage drop from here will be the voltage drop from here. We also know that voltage in a wire is the same until it hits an element. So whatever voltage you have here will be the voltage here, will be the voltage here, will be the voltage there. Now notice here, we are going to hit an element. We'll hit this resistor, but this is an open wire, so no current can flow through an open wire. However, there is still voltage in here. So there's voltage there. There's voltage there. So this point and that point have the same voltage. Same deal down here. So voltage here, voltage there, voltage there. So those 2 points have the same voltage. So if we know this point has the same voltage as that, and this point is the same voltage as that, if we can find the voltage drop from the top of R1 to the bottom of R1, okay, cool. Then we can find this. So let's look at what happens. So we'll look at 5 amps here. So 5 amps will come up this way, hit this node. Notice this, okay, can't go down that way because there's an open terminal. So all 5 amps will run through R1, and it'll come back and finish its loop. So this was 5 amps all the way through. So we know the resistance value of R1, we know the current running through it. We can say V of R1 is I times R1, which will be 5 amps times R1 is 10 ohms, which will give us 50 volts. So the drop across VR1 is equal to VOC, parallel branches, which is equal to V Thevenin, which is 50 volts. And those are our final values. And if we want to drop them in a Thevenin circuit, so we'll have plus minus. Remember, Thevenin is going to be series. This will be our R Thev. This will be V Thev. 50 volts and 50 ohms. And we still have plus minus VOC over here, okay? So this is our completed Thevenin circuit. Hope that was pretty straightforward. I'll see you in the next video.